We're about 7 miles from the nearest power pole at one of my remote sites. We've been doing some work on this system for a while. This is an early Harris hydro design, wound field unit with a Delco alternator. Typically these operated in the 40 percentile range, 24-volt system. So we're going to upgrade this to a permanent magnet. There's two ways to go. We can use the existing base with the existing runner if it's in good shape. We can put a permanent magnet unit on it, our own version, of course. Don Harris, of course, can do their own permanent magnet upgrades. The other way is with a complete new unit. This particular application is a bit of a problem. Because of the way the cement tower was made, it's not quite big enough to mount our box. So I've had to make an adapter plate, which is basically two-sided. I've got an inset area here because this one was cast into the concrete at a lower level, which is a good thing because it does kind of slow down water leaks that are possible. But it creates a little bit of a problem for us a little bit later on, so I thought I'd show you how to do one of the more difficult ones. We've got some pipe issues also that should improve performance. What they've done here, they've got a 2-inch pipe coming in to a leaky valve. Unfortunately, you can probably hear that. Then they went down to 1-inch PVC piping. And you see that is a piece of 1-inch electrical conduit there for an elbow, which is okay, I suppose. It's not rated for pressure, but it is actually the same stuff. 1-inch union and a 90-degree fitting right here at the end, which is not a good plan. So we're going to increase all this up to 2-inch, and that should improve performance as well. Next step, I got to take it all apart. Back in a few. As you can see, we've got the hydro removed, and we've got a rather leaky gate valve over there, and no way to shut it off. So we're going to deal with that, putting pipe together with it wet. Not exactly my favorite thing, but you got to do what you got to do. I had to warm the concrete up a little bit, and I've got some concrete rated silicone type stuff. It's not silicone actually, but other products like Dum Dum or something like the heavy mastic type stuff works pretty well. Concrete can be kind of a tricky thing to get sealed. I put on an extra generous helping of it, as you can see. It'll probably ooze all over the place, but I'd rather do it once than twice. One thing that we are going to talk to her about, as you can see that the inverter is in the same room as the hydro. If a pipe breaks for any reason, we could have a potentially serious problem with shorting out the inverter. It is a vented style. It's not enclosed. The charge controllers, one's for solar, the other one is for hydro. They'll usually survive this sort of thing, and the heating element, of course, wouldn't matter either. It's only a 24-volt system, so no real risk of electric shock or anything. Okay, I'm going to put the hydro down, or the adapter base down first, and I'll be back with you in a minute. Okay, we've got the mounting plate down. The one of the studs, however, is stripped out and it's not fully cinched down. I'm hoping it won't leak. The new cement anchors that I brought aren't long enough, and it's half a day to get out here, so I guess probably have to wait for another day. Probably have to take it all back up and remount it again if it does leak. Okay, I'm about ready to mount the base. What I used for a sealer on the cement, I probably won't use on the top. I'll use probably just a red RTV up on the top to seal our box to the top of the plate. Our box mounts at about 16 1/4 inches. I'm sorry, 15 3/4 inches. It's about 16 1/2 inch overall, 14 1/2 inch by 14 inch on the inside of the box, which creates an undesirable side effect on an application like this, because you have a little bit of a water ledge here that can kick back up into the runner. But since we're only dealing with a one nozzle hydro, that's not too much of an issue. If we had 3 or 4 nozzles run here, I would be concerned, and we'd probably do something completely different, like bust the cement base off completely and mount the thing on the floor, or come up with a steel box adapter that would enlarge out properly and probably set about a foot high off the ground, kind of similar to what you see here, but built for our hydro. A little bit more involved than what I'm trying to do here today. Back in a few. Okay, we have the installation almost complete.
Okay, I'll start walking up there. How long do you think?
Yeah, go ahead.
Okay.
The pipe's in place, and a little bit more of a rounded deal. Instead of any sharp bends, we got 45s on it. It isn't quite kosher, but it's better than what was there. We're about ready to solder up the wires. When you have electrical terminals in a wet environment, or a potentially wet environment, crimp connections and chair lugs and stuff like that just don't work. You really do need to solder it. Let's see. Back in a few minutes. Okay, as you can hear, we've got quite a bit of air in the pipeline, but we were producing 13 amps from 7.2 with the old unit, so that's a sizable increase from where we were. And we do definitely have an air in the pipeline problem, which will probably increase output some more. Once that's purged from the system, we had to shut the pipe off in a rather unconventional fashion in order to do the pipe work. So that's going to take a day to clear out due to the length of the pipe. But anyhow, I expect probably 14 amps, so nearly double what we had. Typically, we're going to get about 70% more output by going to the permanent magnet from the Delco on the early model Harris. Not quite so much with the later Ford high output versions, probably half that difference. So the remainder of the increase is due to the increase in pipe size. Goodness sakes. Anyhow, there you have it basically. In summary, we used the existing cement tower with an adapter plate. There's a little tiny bit of a leak on the back side, so in a couple weeks I'll come back out and remount the thing with new cement anchors. Hopefully it won't crack the cement, but it should be good enough for that. It's about not quite 2 inch thick. I'll use kind of a rope caulk on it this time instead of the squeeze tube stuff. A little bit stiffer, more body to it. We do have a ledge on the inside, which I can hear a little bit of that being kicking back up. Occasionally the runner slows down, but not a big issue. 1 or 2 nozzles, that's okay. 3 or 4 nozzles, you want to probably do a little something different. Probably bust off the cement base and put on a complete new tower made out of steel, and bolted directly into the floor, or whatever you happen to have. Most people don't have them inside a building, so this is a little better than most in that respect. Electrical's all in. Let's see what else. We are going to talk to her about the position of the inverter. It is possible to build on the outside of the building and remount the electrical stuff out there. Another option would be to actually extend the building and put the hydro out there instead, so we got 2 different ways we can go here. Might actually be easier to do a new hydro base. Okay, well, I think that just about covers it.